we're gonna look at the bonus problems. Before that, I do want to mention that I posted a practice exam under week 8. So we haven't covered everything. Let me share the screen with you. But you have 2 weeks to finish the practice exam, just like your first practice exam. Okay. I have a little bit trouble opening this. All right. So let me share the screen with you. Okay, as stated in the syllabus, our second exam will be, will be week 11. Okay, so I have a date for that, November 3rd, but again, it's gonna be I'm gonna make it similar to the first exam. You have the whole week to take it. You can use that Tuesday. We won't have class on that Tuesday. You can use that Tuesday to take the exam, or that whole week you have it to take the exam. So next, under week 10, October 29th, will be our review. So I will give you the solutions to the exam 2. Sorry, not exam 2, practice exam 2. So you have to turn it in on October 27th. You can turn in after the review class because the solutions will be given. So you have 2 weeks to do that. Okay, all right, let's look at the one I posted under week 8. So week 8, the homework assignment is posted there, but also notice that one more time, I have videos created for each homework problem. So if you have trouble doing any of the homework assignments, any of the problems, you should be able to find an example there to help you besides the class videos. All right, because when you watch if you did come to the class and if you missed the class, you should certainly watch the class video, the whole video. But if you did come to the class, you just have like a few questions, problems you have trouble doing, maybe you can watch those videos. But again, you can also go to watch the class videos. They are all posted under each week. Usually under Thursday, after Thursday, I post all the videos there. So like the class notes or the recorded class. Okay, all right. So under week 8, I posted the practice exam 2. So it's due on October 27, not accepted after the class on October 29. So make sure you turn in before that. Otherwise, you won't be able to get points. Okay, and so exam 2 will be harder than the first exam because we cover more difficult topics than the first exam. So you can kind of see what the problems will be like. Okay, so let's see. After this week, this is week 8. After this week, I think, so right now we already talked about these. You should be able to do the problems on page 1 and maybe the top one, page 2. After this week, you should be able to do most of the problems here. Maybe just a couple of problems we will finish next week. Okay, so that's just something about the exam. You can start early to work on that. Okay, and just a reminder, there's a homework due today, homework assignment due today, homework 7. If you have questions, have trouble, let me know. All right, so now we're gonna go back to the, are there any questions? Okay, if not, let's go back to look at what we discussed last week. And look at the bonus problems. Okay, so on Tuesday, we talked about how to multiply, how to multiply rational expressions, and that just kind of more like factoring problems, because you have to. Sorry, that's addition. So we. All right, so that's what we discussed last Tuesday. How do we multiply those rational expressions? We have to factor each of them, factor top, factor the bottom, factor top, factor the bottom, and to get those and found the common factors that we can cancel or cross out. Okay, so that's what the first type of question we learned, and you should have similar questions on your homework assignment, week 7. And the second type of question we learned last Thursday was adding or subtracting rational expressions, which is also similar to adding fractions. You found the least common denominator, equal denominators, and add the numerators. All right, and the only thing might be a little bit new is how to find the least common denominator if we have variables. So we did talk about that, and the process is very similar to looking for the LCM of numbers. Okay, then we also talk about division, how to divide polynomials using long division. So these are the 3 types of questions we discussed. So in the bonus, we had a subtraction. The problem, okay, let me see if I can. Try to maybe rewrite these ones. So the first thing we want to do is to find the least common denominator. Notice that the denominators, one of them is a squared. I think one student thought it was 2a. This is not 2a. 2a and a squared, they're different. 2a means 2 times a, or a plus a, but a squared only means a times a. It's not the same as 2a. Okay, so we want to find the least common denominator. If you can see it, it's actually just a squared times a plus 1. If you have trouble seeing it, you can do what we did before. Break down a squared as a times a. Break down a plus 1, which we can't. A plus 1 cannot be factored, which will stay as a plus 1. And bring down 1 from each column. So we have a times a plus 1, which is a squared times a plus 1. So that is our LCD, or you can call it LCM of the denominators. And once we decide this is our LCD, we want to change both denominators to that. So which means I need to multiply a plus 1 for the first fraction, top and bottom. Because after I multiply a plus 1, the bottom will match the least common denominator. And for the second fraction, I already have a plus 1. I just need to multiply a squared. So multiply both top and bottom by a squared. That's going to give me the same denominator, least common denominator we need. Now we are going to, what is this? Keep the denominator, the common denominator, which is a squared times a plus 1, and add or subtract numerators. So we're going to distribute 3 times a, 3a, 3 times 1 plus 3, and there's a minus sign, minus 5a times a squared, that's 5a to the third, because a times a squared is a third. And you can leave it as it is, because there's nothing to combine in the numerator. Okay, so that's the first bonus problem. Any question? Now the second one is long division. So let's get a new page to do that. All right, so 6x squared, 6x squared, 6x squared minus 5x plus 7 minus 5x plus 7 divided by x plus 3. So first we set it up, and we follow those 3 steps we discussed. So first step, we want to decide how many times x goes into 6x squared. We can do division. If you have trouble seeing it, how many times, you can do division. So remember, this sign right here just means divide, right? So you divide 6x squared by x. So that gives us 6x. 6 divided by 1 is 6. X squared divided by x is x. So I'm going to put a 6x up there. That's the first step. Second step, you're going to have to multiply 6x with both of them. So if you can see it, you just do 6x times x, 6x squared. 6x times positive 3, that's positive 18x. Some students made mistakes in the multiplication. Maybe you should write it down. If you have trouble, if you make mistakes doing that way. So just write down, we're doing 6x times x plus 3. You distribute 6x to x, 6x squared, and 6x times 3, that gives us 18x. Now the next step is to do subtraction. To subtract, I'm going to put a minus sign here to remind myself I'm going to do subtraction. 6x squared minus 6x squared, they cancel. Usually the first terms always match, so they always cancel when we do subtraction. Now here, we're going to do subtraction of sign numbers. It's like doing negative 5 minus positive 18. Again, if you have trouble doing vertically, maybe you should write down horizontally negative 5 minus positive 18. We do keep, change. So that's going to give us plus negative 18. So it's like equals negative 5 plus negative 18. We reviewed the rules before. So when you do subtraction, it's like adding the opposite of the next number. Now we add them. We add these two numbers. Negative 5 plus negative 18, that gives us negative 23x. So some students made mistakes in the multiplication. Some students made mistakes in the subtraction part. So now we're going to repeat these 3 steps again after we bring down plus 7. So we take negative 23x, divide by x, get negative 23. That's a minus there. Now we can do multiplication. Negative 23 times x, negative 23x. Again, negative times positive. That gives us negative here. And something had a positive there. So negative 23 times 3 gives us negative 69. Okay, now let's do subtraction again. So minus here. They cancel out. Negative 23 minus 23. Anything minus itself will be 0. But right here, positive 7 minus negative 69. So we do keep, change. Then we change them both to positive. So that gives us 76 as a remainder. Okay, the final answer will be 6x minus equals 6x minus 23 plus 76 over x plus 3. Any question? Okay. All right. So if you still have trouble with long division or subtraction of rational expressions, make sure you watch those videos and come to my office hours. Okay. So now we are going to look at this week's. Maybe go ahead and let me bring up the worksheet this week and take a quick look what we're gonna learned this week. Okay, so this week, today we're going to talk about how to solve fractional equations. You may recall that we did something fractional equations in section 2.2, which was also on the first exam type, but there's something different. I'm going to talk about it. Okay. 4.7, it's the same type of question, just more difficult. I have videos made and posted under 4.7 for those two bonus problems, but I probably don't have time to cover them. If I have time, I will give you the examples, but otherwise you just have to watch the videos if you want to do those problems after class. And then we will talk about chapter 5, which is going to talk about negative exponents and also the radical numbers. Okay, so that's what we're gonna. And after this week, like I said, you should be able to do almost every problem except one, I think, except one problem on the practice exam. Okay, I'm gonna have to wait next week to finish that one problem. Now we're gonna look at solving equations. I'm going to ask you to compare. So first I will let you take a look at these. The first problem is the one we did in section 2.2. Solve linear equations involving fractions. We got fractions here, fractions here. Today, the new section 4.5 is called solve fractional equations. We also have fraction here, fraction here. We call it rational expression. The difference is previously the denominators, they all are numbers. We may have variables as in the numerators, but no, we didn't have any variables in the denominators. But in this section, you could have variables in the denominators. Okay, I know in the first exam, many students actually did not get rid of the denominators. They kept them as fractions. They try to deal with the fractions. It is correct if you can, make sure you don't make mistakes when you're adding, subtracting fractions. With the variables there, it's even harder. But we did talk about those just recently, how to add, like the bonus question, add, subtract variables with the fraction variables. But again, those are usually harder. So I still recommend that whenever you have fractions in the equation, get rid of all the fractions. So I recommend that way, especially for the bonus question. Like the bonus question examples here, like these two questions. The way you try to do before, as we did in the first exam, try to add or split as fractions. Oh, okay. So is my microphone not very clear?
It just kind of keeps cutting in and out. Like, I don't really know how to explain it. It's just not very clear like it normally is.
Okay. I guess it might be. Let me see if I can. Might have to restart it.
I mean, it sounds better now. I don't know if you just had to move something, but it sounds fine now.
Okay, hold on. Let me just kind of switch a little bit. Well, I have to probably try to restart my computer, see if it can fix the problem. Okay. Or I don't know if it's because I'm using two Okay, give me a second. All right, so can you hear me? But hold on. All right, Garrett, can you hear me clearly now?
Yeah, it's fine.
Well, but this computer I'm using, I don't have my PowerPoint slides there. I'm trying to restart the other computer, see if it will fix the problem. We'll come back to that one. Okay, so hold on. So right now, I'm just gonna ask you to recall why I'm restarting my computer. Or it could be my internet. Well, I don't know. So while I'm restarting the other computer, I'm just asking you to recall what we did with the fractional equations. When you see fractions, again, you can choose to keep fractions to work, with the fractions. But if I want to choose to get rid of them, especially for the bonus problems, you will not be able to do the first way to keep all the fractions, to add fractions, subtract fractions. You won't, that way it won't work anymore. So you will have to get rid of the denominators. How do we get rid of the denominators? So when you have an equation which contain fractions in there, and I want to get rid of all the fractions, what should we do? Anybody remember? I'm not talking about. Hello, can everybody hear me clearly now?
Yes.
Yes. Okay. I guess restarting the computer did fix the problem. Okay. So let me bring up the. Hopefully, it's not because of sharing the PowerPoint. Okay. All right. So take a look at the first problem we did. This was the example I went over. I talked about in section 2.2. It's probably the first week. Does anybody remember if I wanted how to solve this equation?
Multiply each term by the least common multiple.
Yes. Okay. We usually call them least common denominator because the least common multiple of the denominators. Exactly. Okay, so that's the way we did it before. Again, like I said, in the first exam, I noticed many students who did this way, they kept all the fractions, divide by 5, divide through, and that they try to combine all the variables. So many students did this way. I think half of the students did this way. This works if you don't make mistakes. But again, I did notice many students who made mistakes when they are trying to add or subtract variables. The fractions. So I don't recommend this way. And again, this way will not work with the bonus problem in section 4.5, but 4.7. Okay, so let's take a look at, this should be 4.6. In this case, what we're going to find out the least common denominator is 15. So 3 and 5, they both go into 15. And we multiply both sides by 15. By 15. And on the left-hand side, since we have 3 terms, we got to distribute 15 to all of them. So a common mistake was Ray, right? I think Ray said multiply each one by the least common denominator. So you got to remember, you can skip this step, but you make sure you got to remember that you will multiply every term, including x and minus 4. Even if they are not fractions, we still need to multiply them by the least common denominator 15. The reason is whenever we multiply a number, we multiply both sides by that number 15. And the left-hand side, if you have a plus or minus, that means you got to distribute that 15. The left-hand side has more than just one fraction. X is also on the left-hand side. Minus 4 is also on the left-hand side. So both of them still need to be multiplied by 15. Okay, so just pay attention here. After that, what we did was to reduce those fractions. 5 goes into 15 3 times. So you will end up with 3 times 3x plus 1. And these ones, I can just keep them here temporarily. And 3 goes into 15 5 times. So we end up with these. And no fractions anymore. So we just distribute, and combine like terms to solve for x. So that's the way we did it before. Again, that was the way I highly recommended it when I taught this section. Here, for section 4.6, we're going to do exactly the same way. Again, for problems under 4.6, you may be able to keep them as fractions. For the, I think for the first example, but not all of the problems you can keep them as fractions anymore. So here, let's do the same way as we did before. Found the LCD. So we talked about how to do that when we try to add rational expressions. So we look at the denominators, n and n. That's the only one. So the least common denominator has to be n. Just like if you have a 3 and a 3, the least common denominator has to be 3 because n goes into n goes into n. So there are many quick ways. I also gave you a tip in class last week. If you look for the LCD for the variables, pick the one with the highest exponent, right? N and n, they have the same high exponent, 1. So of course you just pick that one. So if you remember the tip, you can also use the tip. The worst case scenario, say I forgot all the tips or the definition, you can use the way we learned during the first week. We reviewed how to look for the LCM. If you remember that, you just break down n, which we can't. We break down this n, which we can. Line up with the same variable. Bring down, we only have one column, so bring down one from each column, which gives you n. So there's many ways to determine what the LCD is. Now, after we figure out the LCD, we multiply both sides by the LCD. The left-hand side by n, the right-hand side by n. Now, the left-hand side, let me put it, only has one term, which is this fraction. And I put n in as a fraction, which is easier for us to see, to multiply. On the right-hand side, we actually have 2 terms, 10 plus. Whenever you have plus, that's like 2 terms or minus. So we distribute n to both of them. That gives us 10n plus n times 5 over n. So n will be n over 1. Okay, now let's, so you can actually skip the step that I put, multiply both sides by n. You could skip that and just go ahead and get this step directly, which is multiplying every term by the least common denominator. The left-hand side only has one term. That's the only term, multiplied by n. The right-hand side, there are two terms, so we multiply 10 by n, and we multiply 5 over n by n. And I put 1 underneath n, and that just changes to the fractional form. So when we cancel, and notice this is something we discussed last week, and actually the week before. So when we multiply, then we've canceled the common factors, because this is multiplication. Look, that's multiplication. Its top is n times this, bottom is 1 times n. So the top n cancels bottom n because it's a common factor. And the same right here. Let me go ahead and just copy down what's left. So after we cancel this n and that n, the top has 35 minus n. The bottom just becomes 1 and 1, and that which can be omitted. On the right-hand side, we have this 10 times n. And that n can also cancel this n because it's multiplication. That makes n a factor of the top, this meant n a factor of the bottom, which can be canceled. So we're only left with a 5. So after we multiply both sides by the LCD n, we get a very simplified equation. 35 minus n equals 10n plus 5. Now, we solve it like we did in chapter 2, the section 2.1, combine like terms. You should also have learned this in DO5 class. So 35 equals 11n plus 5. And we subtract both sides. Subtract 5 from both sides. So that's 30 equals 11n, and divide both sides by 11. Okay, so that gives us n equals 30 over 11. And you make sure you check your answer. You can use your calculator to check your answer. Plug it in and check. So especially for section, you may possibly get some what we call fake solutions. So they may be solutions of this simplified version without fractions, but it may not be the solution of the original one. Okay, a quick tip is usually if you plug into the bottom, it doesn't make the bottom equal 0, and that should be okay. Make sure you don't make mistakes. But again, you can use the calculator to check. So for this section, this is a required process. It's required. Previously, it's optional. If you have time, you check it. If you don't have time, you don't check it. But for these problems, we must check our solutions to make sure it doesn't make the bottom equal 0. Okay, so that's the first example. The new thing compared to the problems we did before is the denominators may contain variables, but the way to solve it is exactly the same. Find the LCD and multiply both sides by the LCD and get rid of the denominators and then combine like terms to solve. Okay, any question? All right, there is a different way to do this problem, to divide through, but I don't recommend that way, again, because adding rational expressions is not easy as combining like whole numbers. So, and also for problems, some problems like this one. Okay, so I'm gonna, like this one here. We'll not be able to do it that way we did before. You did before, keeping all the fractions. Okay, so let's look at this example. Fractions. First thing is we see we have fractions on the left and on the right. Secondly, they're the variables in the denominator. And thirdly, for this question, we really cannot say, okay, let's do 4 divided by 5x, 4 divided by -2. Unfortunately, that's not true. We don't have such formula. You cannot divide like that. It doesn't work this way. Okay. So let me kind of go over. So if you have a plus b over divide by 2, you can do a over 2 plus b over 2. Divide each of them by 2. But if I have 2 on the top, a plus b in the denominator, it's not equal to 2 over a plus 2 over b. I can give you a very simple example. Let's just plug in numbers in there to check. So if I have 2 over, say, 1 plus 3, we know we're supposed to add first because that's considered as parentheses. So you have 2 over 4, which can be simplified at 1/2. But if you say, can I divide first? Apparently that's true. That's not correct, right? So if you do that, and you're going to see, you end up 2 divided by 1 or plus 2 divided by 3. And that's going to give you 2 and 2/3. That's definitely much bigger than 1/2, right? See, if you divide 2 over 1, you're going to get 2. That's impossible because 2 divided by 4, it's a number less than 1. There's no way you can get a number bigger than 2. That's why we said this is wrong. Okay, so this is sort of similar to the second case. You're not going to be able to divide through anymore. So we have to do the way to get rid of denominators. Okay, so here I'm going to give you 2 solutions. The first solution is the same way as we just did to find the LCD by the LCD. But luckily, this problem is a special equation. Compared to the previous example. We have like something divided by something equals like a 10 plus something divided by something. And that's not a special case. So I will show you a quick solution for this problem. So first, let's just do the traditional solution. Found the LCD. Now, from the homework last week, you should be able to tell what the LCD is now, looking at these 2 denominators. Okay, anybody tell me what you think the least common denominator is? Tell. It's very similar to, if I give you addition, say if I give you an addition question or subtraction, you still have to find the least common denominator. We did something like that last week. Does everyone know what the least common denominator is?
Is it 10x minus 2?
10x minus 2. How did you get 10x minus 2?
I just thought like 5 and 2 both go into 10, and then 1 and 2 both go into 2.
Both. Oh, well, the least common denominator has to contain both of them as factors. So you said, did you say 10x minus 2? Is that what you said?
Yeah.
But x minus 2 is not contained in here. How do we, because when we say containing in there means you can write this as 5x minus 2 times something, but nothing. If you put 2 here, 2 times 5x does give you 10x, but 2 times negative 2 will not give you negative 2. So 5x minus 2 is not in here. So if I think about, for example, when I say 2 goes into 6, what does that mean? It means I can break down 6 as 2 times 3. That's when I say 2 can go into 6 or 3 can go into 6. So the same way, when we want to say 5x minus 2 goes into this, it means you can write 5x minus 2 times something equal that. 5x minus 2 times nothing can be equal to that. So when you look at this, maybe you are thinking this as 5x times 2. I'm not sure if that's what you're thinking. I actually don't understand the process. You're saying 5x goes into 10x, but when we say factor, the entire bottom, the entire denominator has to go in there, not just the part of it. 5x can go in there because this is minus and not times. I don't know if this makes sense to you. It looks like there's still confusion about least common denominators. The new thing is, this is something if you never seen before, this is very different. 5, there's a minus there. In the previous, when we talk about least common denominator, we never have minus in there. We don't have minus in a number. But If you have a minus in a number, and again, go back to the process. So if you have trouble understanding the process, how do I find the least common denominator of 6 and 4? Remember the way we did it before? How do we find the least common denominator 6 and 4? There are 2 ways to do. Does anybody remember? If you remember one of the ways, you can let us know. There are 2 ways. We reviewed those during the first week. Anybody? How do we find the least common denominator in a 4 and a 6? 6 and 4. What do we do? What can we do? Besides saying, oh, I just can just see it, it's 12. Okay. We really want you to do it, because for bigger numbers, you're not going to be able to see. So what's the method to look for the LCM, least common multiple? Anybody? That's what we did during the first week, right?
So like 6 would be like 2 and a 3.
Mm-hmm. Yes.
And then 4 would be 2 and 2, and then you bring them down.
You line up the same number, and if you don't have one, you create a new column for that, and you bring one down from each column, right? Yes, that's right. Exactly. Okay, that's one way. What Abby just said is one of the ways to do it. The other way is you can double the numbers, like multiply by 2, 3, so you can double it, triple it, and keep doing this until you found, so 4 and times by 2 will be 8, times by 3, until you found something in common. But this way usually doesn't work for big numbers, and it doesn't really work for our expressions, because you may have variables in there. You cannot just double it, triple it anymore. So this way it doesn't really, it's not the general way. It only works for special cases. So this is usually the common way. And so when we say 12 is the least common denominator, because why? Because 12 equals 6 times 2, and because 12 equals 4 times 3, because 6 goes in there, 4 goes in there. So the same idea. How do you find something such that both of them will go in there? Both of them will go into what? Go into something. Say it again.
X minus 1.
Wait, x minus 1. Does 5x minus 2 go into x minus 1? Does this go in here? So when we say go into, for example, 6 goes into 12, right? Or in the other words, 12 contains 6. So does x minus 1 contain 5x minus 2? Does it contain in there?
Maybe 10x minus 2, 10x squared minus 2.
Okay. So again, it looks like I think there's still confusion here. 10x squared minus 2. Or 10x minus 2. That's what Abby said at the beginning. And I explained that why it is not correct, because when you say this contains that, what do we mean by 10x this contains the other? It means you have to write it as multiplication when we say contain. 10x minus 2 contains, how do we, so the question is, does 10x minus 2 contain 5x minus 2? How do we know, why do we say contain? When we say contain, actually, I omitted something as a factor. Contain means as a factor. Just like 12 contains 6. Why do we say 12 contains 6? Because 6 times 2 is 12. Why do we say 12 contains 4? Because 4 times 3 equals 12. So if you say 10x minus 2 contain 5x minus 2, that means 10x minus 2 equals 5x minus 2 times something. But times what? 5x2 times what will give you 10x minus 2? Can you find a number or anything here? Can we? Is it possible? Is it possible to find something here such that 5x minus 2 times that equals 10x minus 2? It's impossible, right? So what can you say if I put a 2 here? What's 2 times 5x? 10x. And then what's 2 times negative 2? You get negative 4. Well, it's not equal to that. So there's no way you can find anything to multiply with 5x minus 2 to get that. So you cannot say this contains that. So really, it does not contain that. Okay.
So would it be 10x minus 1?
If I change it to 1, will that make a difference? Look, if I change it to minus 1, can we find something times 5x minus 2 to get 10x minus 1? Is that possible? So 5x minus 2 times what will give us 10x minus 1? Can you find a number? Because if you put 2 here, in order to match 10x, you have to put 2 here. If you put a 2 here, you're going to get a minus 4. There's no way you're going to get a minus 1, right? So if you can't find it, you cannot say 10x minus 1 contains that either. I think the confusion is still when we say contain, I don't know what you guys picture it as contain. So contain means here, contain means multiplication. It has to be multiplication. So if it's not a multiplication, it's not going to work. So you have to have something times 5x minus 2 to be equal to 10x minus what, to be whatever that is. But there's no way you can get that. Okay. So if you change it, say, can I change it to 10x minus 4? Okay, it works. Yes, 10x minus 4. If you change it to minus 4, it does contain this. But unfortunately, it does not contain 2x minus 1. 10x minus 4 is not going to contain that. See, how do I know that? Because 10x minus 4, there's no way you can multiply 2x minus 1 times something to get that. What times 2x minus 1 will be equal to 10x minus 4? Nothing. There's no solution. Because if I put a 5 here, you're going to get 10x minus 5. It's not going to be equal to 10x minus 4. But you have to put a 5 there. Why? Because in order to get a 10x there, you have to put a 5, right? So there's no way you can find something that if you try to just kind of change the numbers here and there, it's impossible to find something to contain both. Okay, so neither of that works. I'm not sure if you guys understand this. When you say a number, you need to explain. When you say something like 10x minus 1 or 10x minus 2, you have to justify that. How do you justify that? So for example, when I say 12 contains 6, how do I justify that? Because 12 divided by 6 equals 2. That's why we say it's a whole number. Okay, maybe I can explain this way. Maybe it would be easier for you to understand, you guys to understand. So let me change my explanation here. All right, so let's go back to the of contain something as a factor. What do we mean by that? So when I say, let me ask you a question. Does 18 contain 9 as a factor? Can you answer that question? Does 18 contain 9 as a factor? Yes or no? You can type your answer in the chat box if you.
Yes.
And why? Explain that. That's the important part. Why does 18?
Was 18.
Wait, hold on. Say it again.
9 times 2 is 18.
Yes. Or in other words, 18 divided by 2. What do we get? We get a whole number, an integer. Okay. So if you're saying the same thing, if you're saying 10x minus 1 contains 5x minus 2, then similarly, when you divide them, you should get a whole number or a whole like some kind of expression. But can we divide them? How do we divide them? We can't divide them. You do long if you can do long division. We just talked about last week. Okay, So if you do long division using what we just discussed, do we get a remainder 0? Yeah, 18 divided by 2 is exactly 9 times. The remainder is 0. So when you divide 18 by 2, sorry, I said 9, right? I switched. Okay, because 18 divided by 9 is equal to 2, you get remainder 0. That's why we say 18 contains 9. But if you say 10x minus 1 contains 5x minus 2, when you divide them, you should get just a quotient, no remainder. But look, is that possible to get no remainder? It's impossible. See, you get a remainder 3. So you cannot say 10x minus 1 contains 5x minus 2. Does it make sense this way, this explanation? So is Abby or Jenna, are you clear why 10x minus 1 is not correct, or 10x minus 2 is not correct, is not the correct answer?
Yes.
Okay, all right. So because when you divide this by that, just like when you divide 18 by 9, you get remainder 0, but 10x minus 1 or minus 2 doesn't matter what, this is, unless it's 4. If it's 4, yes, it's actually, it does contains that. But unfortunately, 10x minus 4, you also want to make sure this is this contains the other one. But when you divide then the remainder, when you divide 10x minus 4 by 2x minus 1, the remainder is not going to be equal to 0 either. So that's the remainder is equal to 1. So that means it doesn't contain 2x minus 1. Okay. So like I said, the way is, how do you find something that contains both? How do you find something that contains both? A very quick way is just multiply them. If you multiply them, they definitely will contain both. I give you example. How do you find something that contains both 4 and 6? You can multiply 6. What do you get? 24. 24, of course, contains 6 and 4. It's just not the smallest, right? Because smaller one, which is 12. Okay. So when you multiply them, it would definitely work. It's just not going to give you the smallest. How do we get the smallest? The way Abby said later, break them down and bring down one from each column. This will work. Okay, so this is the way that solution you're going to use to find the least common denominator. Denominator or least common multiple. When you have expressions, it's not going to be as easy as numbers. When you look at numbers, you will say, oh, 12. Most of the students can tell. But when you look at expressions, it's not that easy, okay, anymore. You can't just kind of, oh, I think it's 10. It's if you have to say it, you have to verify it. And actually, after we verify it, it's really not, the least common denominator. So one way you can do is to take the same approach as we did before. So you're gonna take this 5x minus 2. This is like the number 6, okay, but much more complicated than 6. And you try to break down. So we broke down 6 as 2 times 3. Now we try to break down 5x minus 2. Okay, breakdown. When we say breakdown, I mean factor. We talked about factoring before the first exam, and we were using factoring for the past 2 weeks to rational expressions or simplify rational expressions. So how do we factor 5x minus 2? Can we factor this as something times something? Is there any way? If you don't know, and then you can start with the methods we learned. GCF, do they have any greatest common factor? Do they have anything in common? 5x and a 2? Is there anything in common? 5 and 2?
No,
No,
there's
right?
not.
There's not, right? So it's not, there's no GCF. You cannot factor out anything in common. Technically, is this difference of 2 squares? Well, 2 is not anything squared, 5 is not anything squared, right? X is not anything squared either. And pretty much after you check, there's no GCF, you can stop. Why? Because there's no way you can break down this any further. X, how do you break down X? How do we break down X? You can't, right? Just like how do you break down 7? You can't break down 7 as anything, like 2 times 3 or anything. X, you cannot break down X as like half of X, you can't, right? So that doesn't work, which means there's no way you can break down 5x minus 2. Okay, there's no way to factor it. just like you cannot factor 7. Okay, so if I factor it, it's just going to be itself. When I ask you to factor 7, you're going to have to say it's just 7. Okay, we want all prime numbers. We don't really, usually we don't want you to write it 7 times 1 because 1 is not a prime number. So it will just be itself. Similarly, how do we break down 2x minus 1? Can we break down 2x minus 1?
No.
No. So you will create a new column for that because 2x minus 1 and 5x minus 2, you cannot line them up because they're not the same. Then they don't match. So we're down. It's sort of like if I ask you to find the least common denominator under 3 and 5. Well, what's the least common denominator of 3 and 5? The least common multiple. What would be the answer?
15.
Yes, it will be just 15 because you cannot break down 3, will just be 3. You cannot break down 5, will just be a column for 5. And bring down 1 from each column, you just get 3 times 5, which is 15. I mean, there's a quick tip. If neither of them is factorable, you will just multiply them. That will give you, because that's the only number that can contain both 3 and 5. If you multiply 3 and 5, of course, whatever you get is going to contain 3 and contain 5, right? So that always works. But it's just sometimes you may get not the smallest. For example, 6 and 4. If I multiply 6 and 4, I get 24. I think that's some instructors teach students to do. They just went ahead and multiplied whatever given to get the least common denominator. But actually, that's not this cannot be called a least common denominator. It can only be called a common denominator because there is a smaller one, which is 12. If they're factorable, you may be able to find something in common. You only need to take it down 1 time, not 2 times. But if they don't have anything in common, see, like this, they have nothing in common. When you break down 1 from each column and multiply them, that's just what you get. What is the least common multiple? It's just going to be 5x minus 2 times 2x minus 1. It's very long. It's not very simple. It's not a very simple one. So that's what I'm saying. It's probably not easy to just look at them to say what the least common denominator is. Okay. All right. So we found out the least common denominator is 5x minus 2 times 2x minus 1. And apparently this will always work. Why? Because it contains this and it contains that. And if you divide, then check what I said previous division. If you divide the first one, after you cancel, then you get the other remainder. And if you divide the second one, you can cancel, then you get this one, no remainder. So that's why, well, this definitely is common denominator. And we verified that this is the smallest because neither of them is factorable. You won't be able to find anything else that can go into. Okay, so now let's write down the least common denominator. In your previous week, in your homework, let me bring up your homework that you did last week. You should have done similar questions, and you were also asked to do. You were also asked to, when you add or subtract polynomials like that, or just like the one we did in the bonus today. Sure. So in your homework, which is due today, under week 7, we did we added the fractions, but with the variables. Okay, so these questions, like those. Okay, so especially like 58. If you go back to look at your homework, see what you did. What was the least common denominator you used for this question right there? Number 58. So what was the least common denominator? Can you kind of get the experience? What? Yes, Jenna, were you going to answer the question?
2x squared plus 3.
X squared plus 3. Is that what you used?
2x squared plus 3.
2x squared plus 3. So again, when you say that, you need to verify your answer is correct. Let me show, actually that's not correct. Why? Because I can show you, so x minus 1. All right, so let's switch back to this. So Jenna, if you said it's 2x squared plus 3, then you're gonna have, how do you prove this is correct? You have to take your answer, divide by x minus 1. You should have no remainder. Well, we talked about long division. Actually, if there's something missing, okay, so you divide to go in there, do long division, and you're gonna find there's gonna be remainder. So 2x squared divided by x, you gotta put 2x here, so you get 2x squared minus 2x, and no more like terms to combine, so you just bring down 2x plus 3, and then you can put plus 2 there. That's gonna give you a remainder of 5. So that means this is not the least common denominator. This does not contain x minus 1. And similarly, if you take this and divide it by 2x minus 3, it's not going to, you're going to get a remainder that is not a 0, which means this does not contain 2x minus 3 either. So least common denominator must contain both of them, but apparently it doesn't contain. So how do we do that? Again, you do the same way like we just did. How do you find the least common denominator? You break down each one. You break down x minus 1. Can we break down x minus 1? There's no way you can break down x. So x minus 1 is not breakable. It's not factorable. It just stays as it is. Again, it's similar to when you look for the least common denominator with 3 and 5. You cannot break down 3. You cannot break down 5. So it's just going to get 3 times 5, which gives you 15. Exactly the same way here. Think of x minus 1 as 3. Think of 2x minus 3 as 5. You cannot break down 3. You cannot break down 5. Which means here you cannot break down x minus 1, you cannot break down 2x minus 3. So the least common denominator will just be x minus 1 times 2x minus 3. Will just be the product of these two. So it's not 2x squared plus 3. Okay, does it make sense? So I don't, Jenna, how did you get 2x squared plus 3? Where does that come from? What did you do to get like squared here?
Multiply them both.
You multiply these, but I don't think the answer is 2x squared plus 3. So you did do this. You didn't multiply them. I think you probably made a mistake in the multiplication. You would get x, you got to do FOIL, x times 2x, that gives you 2x squared. That is correct. But then when you do x times negative 3, you're going to get negative 3x, and then negative 1 times 2x gives you negative 2x plus 3. So you're missing the 2 terms in the middle, which is minus 5x. If you put a minus 5x there, that would be correct. Okay, but it looks like you're missing. So if you did do that, that is correct, but you just made a mistake in the multiplication process. Okay, you got to do FOIL. Negative 1 times 2 is negative 2. X times negative 3 is negative 3. Well, after you combine negative 2 and negative 3, you will get negative 5x. Okay, but usually when we do this type of question, we don't want you to multiply them out. We would like you to leave it as this. Why? Okay, why do we want you to leave it? When you equal a denominator, if you multiply them out, you're not going to be able to see what I need to multiply to get the least common denominator. But if you leave it as this multiplication format, you will see, okay, I already have x minus 1 here. I just need to multiply 2x minus 3. So you will multiply both top and the bottom by 2x minus 3. If you say you multiply it out to get 2x squared plus 3 minus 5x, it's very hard for you to see, oh, what do I multiply here to get that expression 2x squared plus 3 minus 5x. It's hard to see. So that's why you just want to leave it in this format. You don't want to multiply them out. And so you can see, oh, well, okay, so I just multiply 2x minus 3. So that's going to be the least common denominator. What do I multiply here? X minus 1. That's going to be the least common denominator. So that's the reason we don't want you to multiply out. So the same reason, to go back to our problem today. Here. Okay, so we don't really want you to multiply them out. We just want to leave it as it is. And next, so if you still have trouble looking for the least common denominator, please go back to watch the class video on last Thursday, and also, or you can watch the video, extra video posted under each homework assignment. So after determining the least common denominator, I want to leave it. I don't want to distribute and multiply them out. Why? Because the next process. So let's take the least common denominator. And remember from previous example, that was that Raid? Yeah, I think it was Raid who said, after you find the LCD, what do? Multiply each term by the LCD, right? Previously, we had a number, so you multiply every term by 15, by 15, by 15, by 15. And in the example today, I had the LCD is a variable, and I multiply everything by m, by n. Okay, now look at our LCD, much more complicated. This is a long expression. So you want to multiply the left-hand side by that. So this is the LCD, this is my LCD, multiplied by the left-hand side. And the right-hand side, I also need to take the LCD. Again, it's not 15, it's not n, it's much more complicated expression. So this whole thing is our LCD. This is the LCD there. Okay. Any question for this part? So after you determine your LCD, you're going to multiply both of them by your LCD. Okay, so I'm going to highlight my LCD here. So you see this one, I highlighted, is the LCD. And again, notice that I did not multiply them out. I did not use FOIL to multiply them out to combine like terms. Why? Because my next step would be simplifying the rational expressions. So that's why you did also in your homework last week. So you notice that it's multiplication, and multiplication everywhere, right? So it's all multiplication, which means you can cancel the common factors. That 5x minus 2, 5x minus 2, because that's a factor because it's multiplication, you can cross them out. Common factor. The top, we're left with a 4 times 2x minus 1. The bottom is just number 1. You can omit that, right? So 1, you don't have to write it. Anything divided by 1 would be the self. So you get rid of the bottom successfully. So this is the reason why we don't want you to multiply out. Because if you multiply them out here to get, like, say, if you multiply out, you get 10x squared minus 9x plus 2. You're not going to be able to cancel, find a common factor to cancel. You still have to factor this trinomial to get 5x minus 1, so you can cancel the common factor 5x minus 2. So don't multiply them out. Okay, and similarly on the right hand side, we can cancel a common factor 2x minus 1 because times. So we're left with the 7 times 5x minus 2. So after we multiply this long expression, which is our least common denominator, we were able to cancel out the bottom ones. And you from this process, you can see why do we want to multiply these two? Why do we multiply these two? Because if you multiply them, it guarantees you have multiplication. So it also guarantees you have 5x minus 2, which is the first bottom, the left bottom, so you can cross them out. And why we want the LCD to contain the other factor 2x minus 1? Because you can cross them out. Multiplication can cancel. Okay, so you have multiplication here, you can cancel them out. That's why we need a multiplication there. Okay, so after we cancel all the denominators, we end up with a very simple equation. We can just distribute, combine like terms. So that process is easier. We talked about this. We learned this in DO05. We also talked about this in section 2.1. So we can go ahead and combine like terms. So that gives a negative 4 equals 27x minus 14. And we can add 14 to both sides. So that gives us 10 equals 27x, and we divide both sides by 27. It gives us 10 over 27 equals x. And this is fraction is simplified. We cannot simplify this any further. Okay, any question about this one? The first solution. Okay, so this solution is exactly the same way we did previously, like in section 2.2. Find the LCD, like today's first example, even if we have variables in the denominator, find the LCD. Okay, but much more complicated because the LCD is so long, because it contains minus. If you have minus, you cannot refactor this, and you just multiply them. Okay, but this problem is very special. This equation is a special equation. Why this equation is special? Notice on the left-hand side, it's just a fraction. See, something divided by something, 4 divided by something. On the right-hand side, 7 divided by something. It's a fraction on the left, a fraction on the right. In this format, it's also called a ratio. 4 to something, 7 to something. So we have a ratio equals another ratio. Just like in, say, okay, in algebra class, we have, 30 maybe female students to 20 male students. And in maybe English class, we have 60 female students versus 40 female students. But after you simplify, then you will get 3 over 2 here and also 3 over 2 here. They're actually equal to each other. So the ratio of female students to male students in those two classes are equal. So when in that case, when you have a fraction equal a ratio, we can call it fraction equals another fraction. We call this, does anybody know what we call this? 30 over 20, 30 to 20 equals 60 to 40. What do we call this together? Does anybody know? We call this a proportion. So the number of female students to male students in both classes are proportional. Okay, so this equation is a special case. What special case? It's a proportion. And the proportion has a very good property. Does anybody know when you have a proportion, what property does proportion has? Anybody remember that? In DO5 class, we also learned that. Does anybody know? Property of proportion. No? Cross products are always equal. So for example, 30 times 40, that's 1200. 12 times 60, that's also 1200. So when you do cross products in the proportion, they should always be equal to each other. So that's a property of proportion. Okay, so to do this question, there's a different way. Let me show you the second way. Right here. Okay, so I just did solution 1, which is the way finding the LCD and the LCD. But the other way is proportion. So when you have two ratios are equal to each other, cross products are equal. So this is a property we're going to use. Okay, so since this is a proportion, I can do cross products. The left top 4 times the right bottom 2x minus 1. 4 times 2x minus 1. And the right top times the left bottom 7 times 5x minus 2. And after we apply the property, they should be equal to each other. Cross products, so we're just doing cross multiplies, and they should be equal to each other. Again, this is a special property of proportion. And if you look at what we just got, that's exactly this equation we just got is exactly the same as what we got previously after we multiply both sides by the LCD, but much quicker. So we didn't have to look for the LCD. We didn't have to multiply both sides by the LCD. I just used the property of a proportion, cross products are equal. So I can get that immediately, and then you distribute and to get the answer. Okay, but unfortunately, this only works for proportion. If it's not a proportion, you can't do it. For example, in the first exam, we had questions like this. We can't do it because this is not a proportion, because you have this x minus 4 there. If I get rid of x minus 4, you will have a single fraction, that's something over something. So proportion, what does a proportion look like? It looks like this: something over something equals something over something. You cannot have like plus something here or minus something there. Similarly, for this the first example under 4.5, it's not a proportion either. On the left-hand side, we do have the format something over something, left-hand side. But on the right-hand side, unfortunately, we have a 10 plus. If you have 10 plus something over something, that's not a proportion. So proportion, you cannot have that there. Okay. All right. So this second method we learned, second solution for this example is much quicker, but you can only use it when the equation is a proportion. So you need to verify that. Okay, questions? These are the examples in section 4.6. Now, 4.7, I put a star there. This is optional. So I will skip this in class. On Thursday, if I finish everything when I'm supposed to finish this week, I can go over these examples. But if I don't have time on Thursday, you can watch the video, post it on Blackboard if you want to do those bonus problems. And these questions are more complicated, and there's no easier way. You have to look for the LCD. How do you do that? Break down 2x minus 8, break down x squared minus 16. Previously, the example that I gave you, you cannot break them down, right? So if you look at this example we did, when we look for the LCD, 5x minus 2, you cannot factor it. It's not factorable. 2x minus 1, you can't factor it. It's not factorable. So you just copy them and bring them down and multiply them. But the problems in section 4.7, you actually can break them down. 2x minus 8, you can factor out of 2, GCF 2. X squared minus 16, you can factor it as difference 2 squared. So you can bring down 1 from each column. And then this will be your LCD very long, and multiply every term by that and simplify that way. Okay. So that's the general idea, or the steps are the same as the one we did before. It's just more complicated. Again, so I'm going to skip those. So there are two examples, two bonus problems. Each one is similar to each example is similar to one of the problems given there. Okay. All right. So any questions? So that's end of chapter 4. So today we are now we're going to look at the chapter 5. Negative exponents. So I think, all right, so section 5.1. Okay, 5.1, we're going to be talking about integers, as exponents. Now, previously, before the first exam, in chapter talk about exponents, we gave you 5 formulas. See if you guys still remember those 5 formulas. Well, I think today, yes, we will use those formulas. So let's go ahead and review those formulas. X to the nth times x to the nth. Okay, so if you remember any of those, let me know. The first one, you can kind of and I noticed in the first exam, some students are still confused about like the first 2 formulas when we add the exponents, when we multiply the exponents. Okay, so I'm going to maybe ask somebody to tell me what the answer is. Okay, the first one. Natalie? Are you there, Natalie? What's the answer?
Is it x and then m plus n?
Yes, very good. Thanks. Second one. Colin?
Is it x and n?
Yes, m times n. Okay, so in the first exam, I noticed some students got these two confused. The tip is if you have two exponents right beside each other, you will multiply them. So this n is the power of m, but this n is the power of x, not the power of m, and you add them. Okay, the next one, Aiden, are you there?
Oh, yeah, I'm here.
Okay, so what would be the answer for the third one?
Would it be X, Y, N?
X, Y, N?
Yes.
Little small mistake there. The parentheses indicate that you got to take the n copies of both x and y. So in your case, you only take n copies of y. So you're missing. Can you correct your answer?
I'm not sure.
Okay, so let's look at and go over this again. So whenever you have parentheses, you will take n copies of everything inside the parentheses. Okay. So this, I think what these formulas were, we talked about them in chapter 3. So you can go back to chapter 3 to go over those formulas. I have a detailed explanation there, but quick explanation here is whenever we have parentheses, again, n means n copies. So it means you're going to multiply n copies of everything inside parentheses. So which means you got to do n copies of x, y. When you do n copies of x, y, you are going to get n copies of x and n copies of y because each of them will appear n times. So that should be x to the nth and y to the nth. Okay, so these 5 formulas are sort of like the basic formulas in algebra class. So usually if you take any high level math and you will use them, and these are commonly used in physics or other high level math courses. Okay, so now let's look at number 4. It's very kind of similar. Jenna, do you know the answer for number 4? Jenna, are you there? How about Ellie? Are you there, Ellie? No? Abby?
Would it be x n over y? N?
Yes, y to the nth. Okay. So the same reason, because you are going to take n copies of x over y, one copy, another copy, many copies, n copies. So you will have n copies of x and n copies of y, because x, a bunch of x's, and y, a bunch of y's. Okay, so number 3 and number 4, these two are kind of similar because you would take n copies of x and y, and n copies of x and y. One is multiplication, the other is division. Okay, the final one, the last one, what's the formula? Kaylee, are you there? Kaylee Music. Are you there, Kaylee? Ryan, are you there?
Yeah, I'm not sure how to do it though.
Okay, so if I give you this question, will you be able to do that? What's x to the 5th divided by x squared? Do you know what the answer is?
X to the 3rd.
How did you get third?
I just subtracted.
Subtract what? Be specific. Be specific.
5 minus 2.
The top exponent minus the bottom exponent. So go back here. What's the top exponent?
It's m minus n.
Yes, you keep the base x. Okay, so these are the 5 formulas we learned in chapter 3. So again, if you forgot these formulas, and kind of go back to watch those videos again. And we are going to use these 5 formulas again in chapter 5. Okay, so now let's start with integers. So previously, when we talk about exponents, so if I give you 2 to the 3rd, what does it mean, 2 to the 3rd? Jackson?
2 times 2 times 2.
Yes, very good. Thank you. So you will have, you multiply 3 copies of 2, because 3 is a positive integer. When you have a positive integer, it just means how many copies, positive integer. But what if I make this number negative? So what if I want to do 2 to the negative 3 instead of 2 to the positive 3? What does that mean? Well, you should have learned this in D005 class. Does anybody remember what you may have learned in high school? Does anybody know? Nobody? Okay, negative exponent. So what if the exponent is negative? Be careful. A very common mistake was some students thought, okay, well, 2 to the 3rd is 8, right? It's 2 times 2 times 2 is 8. So 2 to negative 3 must be negative 8. No, unfortunately, it's wrong, okay? Please remember, negative exponent will not make the number negative. Negative exponent actually means reciprocal. Reciprocal means flip. You're going to flip the number. Okay, so this is a very important definition. So make sure you don't get negative 8 or negative 6. Neither of them is correct. So I'm going to start with the easiest case. So this is the new thing. What if the exponent is a negative integer, not a positive? For example, 2 to negative 1. So I'm going to start with negative 1, then I'll explain what negative 3 is. So what does 2 to negative 1 mean? This negative exponent, when you see a minus sign in the exponent, not in front of 2, again, this is not equal to negative 2. Be careful. If I want to tell, if we want to tell you it's a negative number, we will put a minus in front of the number. We will never put a number up, up there. So this is not a negative 2. Negative 2, the minus sign is in front of 2, but this negative is in the exponent. So what does it mean? It means what I just gave you, reciprocal. Whenever you have negative 1, it means reciprocal of the base. Reciprocal of the base. The number is called the base. 2 is called the base here. So reciprocal, anybody remember reciprocal? Means you flip the number. Okay, so what is the reciprocal of 2? So in this case, it's 2. What's the reciprocal 2? Jake, are you there? No? Okay. Any volunteer? What is the reciprocal of 2? Does everybody know? Reciprocal of 2.
1/2?
Yes, that's right, 1/2. Thank you. Okay, because 2, you can write it as 2 over 1, right? When you flip 1 and a 2, you're going to get a 1/2. Very good, thank you. Okay, so what is 2 to negative 1? You actually get a fraction. Let me rewrite it. It's not very clear. Okay. So actually highlighter writes better than that. So you're gonna get a 1 over 2. Okay. So you get a fraction. You're not gonna get negative number. It's not negative 1 over 2, it's just 1 over 2. So this negative sign here, what does it mean? It means you flip the number, flip to tell you to flip the base. Okay, so now let's look at what about well, I guess I can give you another quick one. What if I gave you 3/2 to negative 2? What's the answer? What would be the answer? 3/2 to negative 1, sorry, to negative 1. What's the answer?
2 over 3.
2 over 3. Thank you, Garrett. So you are just flip the top and the bottom. Okay, so remember negative means in the exponent means you flip the base. Okay. All right, now what about, now we can talk about 2 to negative 3. 2 to negative 3 just means you got to do 2 steps. 2 to negative 3 means you are going to get the reciprocal not of 2 to the third. So this is going to be, you're going to give you reciprocal of the base with the positive exponent. So this minus right here, what does it mean? It means it asks you to take the reciprocal of 2 to the third. You keep everything else, it's just doing a flip of 2 to the third. So what is the reciprocal of 2 to the third? What's the reciprocal 2 to the third? First of all, you can find the 2 to the third. What's 2 to the third? Which we got it right here, 8. And then what is the reciprocal of 8? What's the reciprocal? 1/8, right? Yeah, thanks, Abby. So the answer will be 1 over 8. Okay, has nothing to do with negative, okay? If you have a negative number, when you take a reciprocal, you still get negative. But if you have a positive, when you do reciprocal, you always get a positive. So the answer 2 to negative 3 is 1 over 8. So here I'm going to give you more examples. All right. So when I do, how do I do 2 to the negative third? Well, one way you could do is, so usually you got to do 2 steps. Technically, you have two ways you can do. So the way I just did is I take this minus means reciprocal, right? So I'm going to first find out, step 1, I'm going to find out what 2 to the third is. When I get rid of minus in the exponent. And then I'm going to flip it. So I get a 1 over 8. The other way to do the problem, you can, because minus means you flip the base. I'm just going to put a flip here. And this 3 means 3 copies, right? So the 2 steps you got to do. You can, what I just did was I tried to do 3 copies of 2 to get 8, and then flip to get a 1 over 8. The other way you could do is I can flip 2 first. If I flip 2, I'll get a 1/2. I'm dealing with this minus in the exponent. And then I do 3 copies of 1/2. Again, you will get a 1/8 because 1/3 is 1, 2/3 is 8. So you get the same answer. So there are 2 steps when you do this, okay? The common solution is probably the first one, but the second one also works. So similarly, if I try to do 3 to negative 2, can anybody see what the answer is? If I do 3 to negative 2.
Is it -9?
Remember when negative exponent means what? What does negative exponent mean? Look, what did you see what I put here? What does negative exponent mean? means flip. It doesn't mean minus. It means flip. So you want to correct your answer? Don't put a minus there. You flip your answer. Huh?
9.
Wait, 9? You got to flip 9.
9.
Yeah, 1/9. Okay, right, Abby? So remember this minus, you don't put minus in front of the number, okay? If I want to do -9, I would not put a minus there. This is how I write it. I would put a minus in front of the number, so you get -9. That's how you get -9. But if you have minus in the exponent, it doesn't mean negative. It means flip. Okay, so when you do the question, you can get rid of the minus first to do 3 squared, which gives you 9. But because it is minus, you got to flip 9 to get 1/9. That's the answer. Okay, so make sure you remember that. So it's a very common mistake. Many students, when they see negative, they think the answer has to be negative. It's actually no. The negative exponent doesn't mean negative. It means what we call inverse or reciprocal. Okay. All right. So let's look at the example similar to the first homework question. Let's see. So we're gonna have, let's say 1 can do 1/2 raised to -1 minus 3/4 raised to -1. So we still have to follow the order of operations to do exponent first. Please excuse my dear Aunt Sally. So parentheses, inside parentheses is just a fraction, nothing to do, but we do have an exponent. So we gotta do the exponent. What is 1/2 to -1? What's 1/2 to -1? Raid?
Is it 2?
Yes, it is. Thank you. Because negative means flip. So you flip a 1 and 2, you're just going to get 2. Thank you. Now, next one, what about 3/4 to -1? Natalie? 3/4 to -1?
4/3.
4/3. Thank you. Very good. Okay, so we finished the exponent. Now we just do subtraction. We learned reviewed this during the first week. We got to equal the denominators. Multiplied by 3. Found that LCD is 3, so we keep the least common denominator, and 6 minus 4 is 2. So the answer is 2/3. Okay, so everything is the order of operations will still be the same. The only new thing is you may have negative exponent in now. All right, the second example would be 2 to well, I can do 3 to -2, which we just did. Oh, actually, that's the one we didn't have in the homework. Sorry. Let me just maybe 4 to -2. We're gonna do 4 to -2 plus 2 to maybe -4. Okay, raised to -1. All right, so follow the order of operations. We're supposed to do parentheses first, and inside the parentheses, we do have operation that we got to work out. Let me highlight the what's in the parentheses. So this is what we need to work on first. And inside the parentheses, we also have an exponent again. So we got to deal with exponent. 4 to -2. Can anybody see what the answer is? 4 to -2. So first you can do 4 squared. Did someone try to answer? Was that Raid?
Yeah, wouldn't it be 1/16?
Yes, very good. You just do 4 squared, you get 16. And because it's minus negative in the exponent, you flip 16, you get 1/16. Okay, what about 2 to the -4? Garrett, can you see what the answer is? 2 to -4?
Isn't it 1/16 as well?
Yes, it is, right? Because 2 to the 4th, you're gonna get 2 to the first you do 2 to the 4th, that it gives you 16, right? 2 times 2, okay. And then you flip it again, you get 1/16. Okay. In your homework, you may not get the same one. The one I have here is luckily I got the same answer. So now I add them together. 1/16 plus 1/16, I get 2/16, which can be reduced to 1 over. Maybe I can reduce later. 1/8. So I flip it to get 8/1. Actually, you can, I can just do this way. 16 over 2, flip it. Negative means flip. So I get 8. Okay. All right. So next, okay. So these first two questions are testing you the definition of negative exponent. Next, we're gonna look at if you have your look at the homework questions. We're gonna use the formulas we just went over right here. Okay, so these exponent formulas. So you're gonna refer to these formulas to do the rest of the questions. So in the first exam, we did questions like these, very similar questions. So I'm going to give you, so a to the 4th times, this was before the first exam, okay? I think it was chapter 3, say negative. Okay, so what's the answer? Everybody should know how to do this one, right? Can someone tell me the answer?
A to the 7th.
A to the 7th. Jackson, thank you. Because the form of the first formula, right? 4 plus 2 plus 1. So that's 7. You add exponents. That's exactly right. So now, so this is chapter 3 we did. Now chapter 5, it's section 5.1. Section 5.1. If you look at the homework question, so what I'm going to do is I'm going to change some of them to negative. For example, I'm going to change this to -4. Instead of +4, I can keep the second one positive and the next one also change it to negative. Well, although some of them some of the exponents become negative, the way to do the problem, you can still use the same formula. Those formulas still work. So remember how we got 7 here? We added 4 plus 2 plus 1. That's how we got 7. Okay, so to do this question, the formula still holds. You can still add exponents, but what you need to be careful, some of them are negatives. So you're going to add -4 plus 2 plus -1. That gives you -3. So the answer will be A to -3 instead of 7. Well, the way you do it is exactly the same. Okay, so when you get here, you can leave your answer this way. If you want put the answer as A to -3, that's correct. Well, sometimes they may give you instructions, say, okay, especially in DO5, they want you to get rid of negative. So if you want to get rid of negative, that would become, so you first do A to the 3rd, just like we did before. And the negative means you flip A to the 3rd. When you A to the 3rd over 1. So when you flip it, you get 1 over A to the 3rd. Okay, so you can still do the, I would still use the formula first to get a single answer, and then use the definition to get rid of it. But in this class, both answers are acceptable. So if you say, I don't want to flip it, I'll just get an A to -3, that is also correct. Okay. I guess I probably will just maybe stop here for today. Okay, let's see. Well, I will go ahead and give you the bonus. So I will finish the rest of it next time. Okay, so the bonus for today. So first one, I'm sorry, not this. I forgot the number. Okay, this is gonna be number 13. Okay, so the first one, we want you to solve the equation. All right. I'm going to, yeah, you can type present and leave. If you don't have a question, you can leave the meeting. I'm gonna post create a bonus 13 so you can submit that way.